Right, this video is a worked example for a trig identity and equation problem. So these are quite typical types of problems in A-level exams. Um, this one is particularly difficult, but I think it's worth doing because there's some good learning points in it. So let us just have a look what we've got. Show that the equation, well, this lot, tan theta, 8 cos theta, 20 sine squared theta equals 8 sine 2 theta into 1 plus tan squared theta can be written as this expression here, which we've got a sine 2 theta, and then we've got this quadratic here with unknown coefficients. So we've got to find A, B, and C. Okay, but first part, then we go on to solve this, but the first part is to actually show that this equation equals that equation. So it's an identity. In this case, we're actually sort of transforming an equation rather than just an expression, but it's the same either way, really. So as with these things, what I need to do is look at what we've got and where we're trying to get to and spot where the differences are. So let's have a look. Now, when we look at this and the target, well, one thing, we've got tangents involved in this, haven't we? Now, tangents, are easily converted into sines and cosines. This one, though, we think we need to take a slightly different approach to. The fact that it's written in this form, 1 plus tan squared theta, should remind us of our identity that this is equal to secant squared theta, and secant squared theta is the same as 1 over cos squared theta. Okay, so we've got some kind of manipulation to do there with those tangents. We've also got a sine squared in there. In our target, we only want well, sine 2 thetas and cos thetas in it, but we've got an easy conversion there between sine squared and cos squared through the sine squared plus cos squared equals 1 identity. So we should be able to use that. Okay, also interesting is that this sine 2 theta here is common. We can factorize this out. Now we've got a sine 2 theta here, but we haven't got one of those on the left. So we may be creating that on the left, because once we've got it on both sides, then obviously we can move the right hand term over to the left and factorize out. Let's just give it a go and see what happens, eh? Okay, so this is what we're starting with. Right, so first observation is 1 plus tan squared theta. We can call that sec squared theta. I think that's the right way to go. And equally, that is, as I've just said before, that's 1 over cos squared theta. Now we're looking at this tan theta over here as well. I'm going to convert that into sine theta over cos theta. So at that point, then what we're going to do is we're going to cross multiply this cos squared theta over here, multiply both sides by cos squared theta to give us this. Right, everything else is as it was. And with some cancellation, that's going to leave us with 2 sine theta cos theta. Now, we'll come back to the cancellation afterwards. I mean, when we, if we're dividing by cos theta, then we have to make sure it's not 0. That's what we're doing this cancellation. We're dividing the numerator and the denominator by cosine theta. But we'll come back to that anyway. So we'll just carry on and do that cancellation, and that gives us 2 sine theta cos theta, which you should be able to recognize as being sine 2 theta. So we've got to this point here. Sine 2 theta equals 8 cos theta plus 23 sine squared theta equals 8 sine 2 theta. Now this is good because we've got sine 2 theta right throughout. So if we actually subtract 8 sine 2 theta from both sides, we can actually factorize out the sine 2 theta and bring the 8 inside the brackets. Now it's starting to look the right sort of thing. We've still got this problem with the sine squared theta, but fairly easy substitution there. Sine squared theta equals 1 minus cos squared theta. So if we do that, work that through, we're going to expand, get that, and then the contents of the brackets are going to simplify to that. And then I think basically this we can just multiply this expression by -1, makes it look a bit tidier. This is not incorrect, but usually tidier if our x squared terms, cos squared term in this case, is positive. So we end up with that. So there we go. That is what we have been asked to show. So without scrolling back up, that is the form that's required. And so we can see from this that A is 23, B is -8, and C is -15. QED, that's what we're required to show. So that's good. All right. Tricky one, but we got there. Right, so now we're looking at the solution to this equation, and we are looking, sorry, we'll have to scroll back up to the top. We are actually looking for solutions in the range 360 to 540. And note here it says x is not equal to 450. Okay, so right, now I've talked in other videos about one-factor solution, one-factor equations. 2 sine theta -1 equals 0, for instance. Easily solved. 2 sine theta equals 1, sine theta equals 1/2, so on. And then there are two-factor solutions, of which quadratics are an example, because if we can factorize a quadratic into two factors, then that makes it a two-factor equation. And now this one, basically we've got two factors wrapped into this quadratic here plus another one here, so this is a three-factor equation. However, it's not actually too demanding. What we're actually saying is that either this is 0 or this is 0. Now we could possibly factorize it and solve it that way. But I've just used the calculator, and so I've stuck these coefficients into the class whiz, and it's given me the solution. So either we've got sine 2 theta equals 0, in which case theta is going to be, well, it can be all these values, although the ones that we're interested in are these two. These others are not in our range. And this or this quadratic here could be equal, quadratic expression could be equal to 0, in which case the solutions to this are cos theta equals 1 or cos theta equals -15/23. Now if cos theta is 1, again we've got all these solutions here, and we're only interested in these two. And for cos theta equals -15/23, then we've got, well, it's negative, this, isn't it? So we're gonna, we're not surprised if our sort of primary solution is between 90 and 180. That's where it would be. But we also have the other -1 in the range 0 to 360, which we find by 360 minus this primary solution gives us 229.29. Right, I found those, but obviously they're not in the range that we require. But if we add 360 to each of these, then we get another pair of solutions here, 490.71 and 589.29. Well, this So the ones in black are not in our range, but 490.71 is. So so we can see from here the three solutions, which are 360 degrees, 490.71, and 540 degrees. Whew. Now, just as a way of a check, I've stuck. I didn't do it with these, but I put 490.71 into this expression. That's a minus there, so I would be expecting 0 to come out of this. I worked it out and actually came to 0.005. So considering that's actually close enough to 0, given the fact that I've done some rounding here on these angles. So I've taken that as a wrap. So there we go. Our three solutions: 360, 490.71, and 540. So the other thing, just to go back to, it does say, well, 450 is precluded, and it's precluded because in our process we have divided by cos theta. That was the cancellation process, remember? And of course, cosine of theta is going to be 0 if theta is 450. So when we do an operation like that, we kind of need to exclude those cases, which of course potentially means that they may be solutions. But in case that's why it says. So if you were puzzled as to why it should just exclude 450, that is the reason. So yeah, that's a pretty tricky question. If you got that in your A-level exam, I think you'd be a bit unlucky, to be perfectly honest. That is definitely at the harder end of these questions. And if I'm perfectly honest, when you go through your paper and look at what to tackle first, if it was me, I think I'd be pushing that a little bit towards the back end. You may be very good at these things, in which case that is fine. But I think this is the trickiest topic, and in the A-level syllabus, and this is a particularly hard question. But hopefully the video has been useful because it's brought out some learning points. If you can do this one, I would say you'd probably be able to do any of these questions that you might be hit with in the A-level exam. Okay, so that's it, and thanks for listening.